This video is for IXL Activity A1.H.1. It is titled Properties of Addition and Multiplication. The 3-character code for this activity is Tango, Quebec, Sierra. So the question asks, which equation shows the commutative property of addition? So we're looking for the commutative property. Well, commutative, if we think about it, whenever we commute, we move from one place to another, right? So we're changing position. So we're looking for a situation where the variables, in this case, are changing their position. So in the first example here, we just see that we have S plus T plus U equals R. Well, nothing's really changing position there, so that's not the case. Here we have S plus R on the left, and on the right we have R plus S. So you see that basically what's happened is that the R and the S has switched location. That means that they've moved from one place to the other. Therefore, they have commuted, so this would be the commutative property. On the other one, let's look at the properties of the other ones, if there are any properties to be discussed. We have R plus S plus T. Look at the order, RST, RST. But here, S and T are grouped together, but here R and S are grouped together, so this is a grouping situation. So this is the associative property, when we talk about who do we associate with. Who are we grouped with? So this is just the regrouping from one side of the equation to the other side. And then on the other one, we have R plus S equals T plus U. That's no property whatsoever. So the correct answer is the second selection. Next question. Which equation shows the associative property of addition? So like we mentioned in the last slide, associative property is all about grouping. So we're looking for where we've changed the grouping of it. And whenever we talk about grouping, we're talking about parentheses, right? We use parentheses to show groupings. So we should be looking for something with parentheses. And the only one we have is the second one here. So we see that we have A, B, C, A, B, C. So the order hasn't changed, so we don't have any commutative property going on. And here on the left, we have B is associated with C. But over here on the right, B has now been associated with A. So we've just changed the grouping. So grouping is the associative property. Notice that here A and B change position. They just flip around from one side of the equation to the other. So this is the commutative property. And this is no property at all here. And this is no property. Actually, this is what's called the closure property, but it's not part of the activity. Which property of multiplication is shown here? So we have the order of ABC, ABC. So notice that the order has not changed, so we can rule out commutative property. And again, we have parentheses, so this is a good indicator that this is the associative property, because the associative property is all about who do you hang out with, who do you associate with, and group. So we're looking at grouping, which deals with parentheses for the associative property, and indeed it is the associative property because over here on the left, B is being multiplied times C, but on the right, it's being multiplied times A. We've just changed the grouping. The identity property would be like A times 1 equals A. Anything times 1 is equal to itself, so we're getting the same thing back. It's like the identity. Whenever you look in the mirror, what do you see? You see yourself. Or if you look at your ID card, your identification card, you see a picture of yourself. So anytime we multiply something times 1, we get that very same thing back. So that's an example of the identity property. And then the zero property of multiplication is that any number such as A times 0 equals 0. That's known as the zero property. Which property of multiplication is shown here? So we have D times F equals F times D. So it looks like all that's happening here is they've just changed position, right? They've traveled from one place to the other. So they've changed location, and that means to commute. Whenever you go from one place to the other or you change position, that is commuting. So that's the commutative property. The distributive property, whenever we do the distributive property, that's like A times B plus C, where we have A times B plus A times C, where we just distribute that value A into both the B and the C. That's an example of distributive property. Again, zero property is A times 0 equals 0. And the identity property of multiplication is A times 1 equals A. Which property multiplication is shown here? Oh, look, we have something being multiplied times 1. We multiply C times 1. We get it right back, so this is the identity property, right? C looks in the multiplication mirror of number 1 and sees itself, so that is the identity property. Zero property would be C times 0 equals 0. The commutative property would be something like C plus B is equal to B plus C, where they just change position. And then associative property would be like A plus the quantity of B plus C is equal to, where we now associate the A with the B and then add the C. We just change the grouping. Which property addition is shown here? So it is addition. We do have addition. So we have D plus 0. And what do we get back? We get D. So this is kind of like the identity property of multiplication. The identity property of multiplication is 1, but the identity property of addition is 0, because anything plus 0 is equal to itself. So this is the identity property. Which equation shows the 0 property of multiplication? Remember, that is any number times 0 equals 0. So we're looking for that example. And right there we have it. 0 equals C times 0, where C is being multiplied by 0, and the result that we get is 0. That's known as the 0 property of multiplication. Indeed, it is multiplying. This is the identity property, right? That's the identity property. Anything times 1 is equal to itself. Here we have C's being distributed into the C times D and C times F, so this is the distributive property. And up here, this is no property at all. Which equation shows the distributive property of multiplication? Well, that's good. We just got done talking about distributive property. So we know that we're going to have some parentheses involved because we have to distribute some number into a quantity. And over here, we see that S is being multiplied times the quantity of QR. And actually, that's not the correct one. They're trying to trick us here. QRS, R and S are together, Q and R are together. Oh, this is the associative property right here. So it must be the other one with parentheses. So let's check that. Q times R and Q times negative S. Q times R minus Q times S. Indeed, this is the distributive property right here. Up here, something's being multiplied times 1, so this is the identity property of multiplication. And this down here is the 0 property of multiplication. Anything times 0 is equal to itself. What value makes W? What value of W makes this addition sentence true? Hint, use properties of addition. So over here we have 19 plus 53. 19 plus the quantity of 53 plus W is equal to 19 plus 53 plus 23. Well, you see we have 19, 53, and W, 19, 53, and 23. Obviously, W must be equal to 23. And notice the groupings are different, so this would be the associative property that we should have used the hint. What value of P makes this multiplication sentence true? Well, we have 46, 73, and P. 46, 73, and 24. The answer must be 24. And it looks like over here we have 46 grouped with 73, but over here we have 73 grouped with P, so this also is an associative property issue. Next question. What value of Y makes this addition sentence true? So some number plus 73 equals 73. Well, this is the identity property of addition, correct? And we know that any number plus 0 is equal to itself. So we have 73. We end up with 73. Therefore, Y has to be equal to 0. What value of K makes this multiplication sentence true? So we have 21 times 9. So some number times 21. In order for these to be equal, K would have to be equal to 9. Notice that the 21 and the 9 have just simply changed position. So that means that the property that's involved here is, well, anytime something changes position, it's commuting. So in this case, it is indeed the commutative property. What value of X makes this multiplication sentence true? So let's see. We've got some number X missing in here, and there are parentheses. So it might be associative property. There's no parentheses over here on the right side, so maybe it's distributive property. maybe we distribute the 80 into the x and the 80 into the 41. Well, here's our 41 times 80. So over here, this must be, in that case, we must have 80 times 1 is over here, right? So this must be a 1 that's over there, so x must equal 1. What value of p makes this addition sentence true? So you might think, oh, great, decimals. I hate decimals. Well, think of it this way. We really don't have to do any addition or subtraction here. We just have to kind of use a property clue. And in this case, anything plus 0 is equal to itself, right? So the 0 property of addition, actually it's not the 0 property. There is no 0 property of addition. There's only a 0 property of multiplication. We're dealing with addition here. So this is actually the identity property of addition. So 108 plus 0 would equal 108.8. Actually, I forgot to say 0.8 there. So that must mean that P is equal to the 436.44. What value of R makes this addition sentence true? Well, let's see. What do we have here? 194, 158, 83, and R. The 158, 83 is accounted for there and there. The 194 and the 194 is accounted for. Then the R must be equal to the 130.8. And it looks like it's going to be the associative property. Indeed it is. The 194 over here is associated with 158.83. But over here, 194, I think they actually changed order and groupings. Yeah, so this is, the order changes, so it is commutative property. And also the grouping changes, so it's also the associative property. Two properties at work there from one side to the other. What value of U makes this addition sentence true? Well, we have 578, 521, 521, and, well, that must be 578. So in this case, all that happened is that 521 and 578 switched positions. So they changed position. That means they went somewhere. It means they commuted. So that is the commutative property. Final question. What value of x makes this multiplication sentence true? Well, let's see here. We have 448.5 times 0. Well, that would equal 0, right? This is the 0 property of multiplication, right? 0 property of multiplication, so that would just equal 0. And then we're going to add that to x times 481. Well, over here, here's our 0. This right here equals 0, and that accounts for this right here. So this portion of it must account for that. So some number times 481 equals 481. Therefore, x must be equal to 1. So here we had the 0 property of multiplication for one part of it. And then we had for the other part here, where we multiply 1 times 481, that was the identity property of multiplication. So again, another problem where we had two properties that were being used in that particular equation. All right, so those are all of my examples for IXL Activity A1.H.1 Properties of Addition and Multiplication. Good luck with your activity.